Vectors and scalars, the basics. So this is part of my new series of I'm doing a series on vectors and showing you how to do different things with vectors and scalars. And right now, I'm not going to be doing any calculations. I'm just going to explain to people who don't know what vectors and scalars are, what vectors and scalars are. Okay, so we're going to start with a scalar because a scalar's pretty easy. So a scalar or a scalar quantity is just something's magnitude. It's just something's size, how big something is. That can include things like a length. It can include things like area, mass, and the temperature. Let's just leave it there. Which means like it's just the size of something, how big something is, or how long something is. It's just how, you know, it's just the size of it. Okay, so the length, an example could be 5 meters. So the size of the length is 5 meters. The area could be 5 meters squared, which means the size of the area is 5 meters squared. That's just how big it is. Mass, 16 kilograms. That's how much something weighs. It weighs 16 kilograms. Or it could weigh 12 pounds if you're in imperial. But that's just how it is. It's how big something is, the magnitude of something. So the magnitude of something could be represented like that because it's just vectors. I'll go into that in a minute, but vectors are just like magnitude and direction. Scalars are just the magnitude. You're not moving anywhere. You're not moving anywhere 5 meters squared, or you're not 16 kilograms in a direction or 5 meters in a direction. 5 meters is the size. 5 meters per second, which is velocity, is when you're moving at 5 meters per second in a direction, which is a vector. But 5 meters on its own isn't moving. An area isn't moving. A mass isn't moving. The temperature could fluctuate, but if something was like, I don't know, 36 degrees Celsius or 54 degrees Fahrenheit or whatever, that's the temperature. That's the magnitude of the temperature. It's the size. It's gone up to this much. It's not moving anywhere. It's not going anywhere. It will, according to different things going around it, but as is, it's not moving anywhere. Anyway, I think I've gone a bit too far, but vectors. We'll talk about vectors now. Vectors, well, that's when you have magnitude and a direction, which means you're moving basically at a scalar quantity, but in direction, which makes it a vector. So these things can include velocity, acceleration, force, and weight. Like when you step on a scale and you see your weight, that's because you have a mass, but you're going in the downward direction, and the spring from the scales is pushing back, and depending how much it has to push back, it shows you your weight. That's because your weight is your mass down in a downwards direction on Earth. Anyway, that's what it is. Your force, when you apply force to something, you're usually pushing in a direction. Like if I went to push a table over or push someone, I'd be applying a force, but it'd be in a direction, because I'd either be pushing them forward, I'd be pulling them back, I'd be pushing to the side, whatever I'd be doing. And velocity and acceleration, that's, if you get in a car and you put your foot down, you're accelerating, your car's going to move forward, or your car's going to move in reverse, whichever you got it set. These are what vectors are. a magnitude, like the size, it could be, the size would be something like 13 meters per second would be, the 13 meters would be the magnitude, and going 13 meters per second forward, that would be the direction, and the magnitude and direction. And that's what a vector is. I'm not going to go into vector addition, but I'll just show you some ways vectors can be shown. The notation for like showing a vector, like this would just be your scalar quantity, and which would be like a number of sorts. But if you put an arrow above it, I like to put a squiggle below it. I've seen this is basically in all textbooks I've come across, and all textbooks you probably will come across. This is just a generic way I've done it, and I've shown by a couple of teachers, just because when you do a squiggle, it's easy to do on the go. When you're trying to do an arrow, sometimes it can come out of something wonky, or if you forget to do the arrow, you've just got a bar, and someone could confuse that with average, and you could have a dilemma. But a squiggle, you can't really go wrong with a squiggle. I always use a squiggle, and I will continue to use a squiggle throughout this playlist, but that signifies that this value is, this quantity, this R quantity is a vector quantity. Over here, this R is just a scalar quantity. This R will be a number, whether it be the 5 meters, the 5, or the 16 kilograms, whatever it is, it's just the size of it. This shows that not only has it got size, but it's got a direction, just by doing the squiggle or the arrow above. I think there are a few different other ways you can do it, but I'm not really familiar with them. And also, say you've got a scalar would equal 5, whereas a vector would equal, this is when you start getting into directions and whatnot. When you have a point on a graph, I'll quickly do this. When you have a point on a graph, let's say here, it's a point, and you use rounded brackets, and you write the coordinates. It's an x coordinate of whatever, and it's a y coordinate of whatever. When you use vectors, because vectors, we try to make them different from a point. It's not an x and y and z anymore. Now, instead of using x, y's, and z's, we use i's, j's, and k's. And when we do like this here, and also we either have a vector going in the direction of 5i plus 2j, or we write it as 5, 2. Okay? What this means is, this here is the point, x and y. If we write the vector, and it equals if we use like little triangle bracket sort of things, and we say it goes up in an I direction and a j direction, and those are both vectors. That means it's not just a point, and there's an arrow, so something is going to that point, and that's when we use these funky little arrows, or we do this, which means this here, these two mean the exact same thing, which means when you have, now we've got, you've got your j and you've got your I. When we travel this direction, say this is our vector, this would be r with the squiggle, we got a vector going this way in the I direction, which would be our I vector, and then we travel this direction using our j vector. And that's when we add these together, we get this. I'll go into vector addition in the next video, but basically that's it. We add this vector to this vector and we get this vector. And that's where this comes in. You have a vector here, which is this one, but the components of it adds this vector and then it adds this vector. And that's how you get, see, the I vector and the j vector and the r vector. The r vector incorporates these two, but these are the components. If you had something 3D and it was going up, it was going to the right, forward, and up, you would be using things like I, j, and k, because k replaces z when talking about vectors. Okay? Hopefully I've explained most of there is to know. Oh, and also some people about this up here, another way of doing it is you do your R and your vector, and then you would have something like it has a magnitude of 10, and you can put the, I've seen some people do the at sign at 45 degrees, which means it has a magnitude of 10 in the direction of 45 degrees from the right. Or I've seen some people go 10, and then they do that, and then put 45 degrees, which that there just means at an angle. And that's sort of how they represent vectors in that way. Anyway, that's basically the basics of what I know on vectors. I hope this video helped you, and I hope you learned something, and I hope you have a good day. Thanks for watching.